afternoon. We are the Dynamics team, and in this video we are going to show a short demonstration of the summation of forces. For this, we'll take an object and drag it across two different surfaces, one on a regular floor and the other one on pavement. Our object has a mass of 0.43 kilograms, and the time was dragged on the regular floor with a distance of 1.6 meters is 1.5 seconds, and the second time it travels the distance on the pavement, 1.2 meters, is the same amount of time. We have several important data points to be comparing these two forces, which will be very helpful later in calculating other values.
With the results obtained, we move on to creating the graphs to calculate the sum of forces. First, we must add an arrow to both graphs, indicating the force we apply to the object, pointing to the right. Next, we have another force, the frictional force, acting on the object, which in this case will point in the positive direction from where we apply the force. Then, there is a force of gravity, which moves the object downwards, and finally the normal force, which counteracts the force of gravity.
After creating the graph, we will calculate the forces on the y-axis, which are the weight and the normal force. Since these values are the same for both objects because it is the same object and no force is applied to either of them on the y-axis. We will first calculate the object's weight by multiplying its mass by gravity, which in this case will be 0.43 times 9.8, giving us a result of 4.21 newtons. Then, to calculate the normal force, we will have to subtract the weight from the force on the y-axis. Since the y-axis is 0, the normal force is also 4.21 newtons. Remember that these values are the same for both graphs.
Next, we will examine the applied force in each situation, its respective friction, and its coefficients. First, we will refer to the first graph and use the existing data to calculate the other values. We begin with a formula for the sum of forces, which is equal to force minus friction and equal to mass multiplied by acceleration. With the data we already have, we cannot calculate the forces because we are missing the acceleration, which we can obtain using the formula acceleration equals 2 times the distance divided by the time squared. Substituting the values, this gives us an acceleration of 1.42 meters per second to the square. To calculate the forces, we also see that the sum of forces always equals 0, so the force applied to the object and the friction have the same value. To find the value of both, we multiply mass by acceleration, resulting in 0.61 newtons for both. Now, we need to calculate the coefficient of friction, which is calculated using the formula friction divided by normal force. Substituting the values, we get the following results: 0.14, and that will be all for the first graph.
Next, we move on the second graph. There we will follow the same steps as in the previous graph. First, we will find the value of the acceleration using the formula, and we have to substitute the values to get a result of 1.06 meters seconds. After obtaining this value, we will measure the forces applied of the object, which as mentioned before, both have the same value and they're obtained by multiplying the mass by the acceleration. We substitute the values to get a result of 0.46 newtons for both forces. Then we will have to obtain the coefficients for friction using the same formula as the previous graph. So we will change the values to ones we have now, and it will give us a result of 0.1. With this, we have seen how the summation of forces is done.